Okay, so let's actually set up our simulation. So I'm going to drop down a oopsies, geometry node once again. It's going to be another sim kind of area here. So we'll call this something like RBD's main, oops, capital, RBD's main sim. Purple for my arbitrary designation for sims. Open it. So what are we going to base this off of? Like, where are we going to put our rigids? Now, we could come up with a whole new thing where we say, I'm going to put them in such and such a place. In our case, let's just grab them from the particles that we actually ended up spawning. So I'm going to say, let's go to this area, the out. And let's see. So here's our particles. And remember, this is actually based off of our low-res sim. If you come back here, the low res is active. You know, when we're in high res, it'll change. It'll take longer to load too. But right now, let's keep it in low res because we're not going to spawn this many rigids anyway. So let's just base off that. So get particles. And even this is really too many. So let's cull this down some more. I'm going to say let's blast out. There's that just born group, right? These are points. So what points were just made? And there we go. So those are the shapes of the blasts on the first frames. And that's where we'll add our rigids in. Because of course we want the rigids to show up at the same time that the particles do. Looks like I lost my particles. And this is still too many. So let's cull it down even more. For this, I'm going to do an attribute wrangler. And as a common kind of thing here would be to say, like, let's come up with a random number based on something. In this case, every point coming out of a particle simulation has its own unique identification number. So we say ID. Now, ran is going to return a number from 0 to 1. So let's compare it to some number from 0 to 1. I'll just call it threshold here, and then if it's less than some number that we come up with, then just delete it. So this is a fun way to just delete a percentage of points. So we say remove point from this geometry stream 0 and remove the point that we're currently iterating on, which is point num. Remember, click this and then kind of move this a little bit so the scroll bar shows up. And you can see as we make this bigger, as we go towards 1, you'll have less. So this is essentially saying delete 100% of the points, delete 0% of the points. Now we do want to get rid of most of them. So let's do some nice even number like that. So that's 781 points. Now that's probably too many. I mean, Bullet could handle it, but I don't think we even want to wait for that. So let's do like half of the remaining amount. So 0.975, that's okay. So that's like 400 points. So it's 400 rigids once we instantiate our rigids to it to use. So okay, that's not so bad. We have some attributes already. We have the velocity, which is super convenient. What we don't have though is a kind of randomized orientation though. So let's do the usual thing, which is make a attribute randomize and say just use an n. There are more exact ways to getting a truly random orientation for stuff, but this is totally like more or less good enough. So there we go. Looks like that. So that'll work. We don't know yet exactly what these are going to look like, but for now I'm going to say we know that we're going to have to mess with the size. We do know that we'll have to do that eventually. So let's drop down let's do a p scale and say, let's do it by ramp actually. So it's one-dimensional because it's just a float. We'll have a minimum and a maximum. We'll just start with some basic numbers for now. Let's say like 0.1 to, well, let's say 0.01 to 0.1. Because remember, this is essentially going to be multiplied by that unit-wide piece of geometry that we just had. And we know we don't want geometry that's a meter wide, because this is just supposed to be tiny little things. We're also going to like make some kind of ramp like this. It'll be, we don't want it to ever really go down to full 0, but we'll make some kind of ramp, and we'll work on this in a minute. But there's some default values for you there. And finally, we need to tell Houdini what pieces do we want to put on there. I like to use an attribute wrangler for this, as I use for so many things. I'll say randomize pieces. When we use the instance, which is what this guy is here, by default, it's going to look at a path, instance attribute, or instance path rather. So what are we going to do is essentially just let's build that attribute right now. So we'll say like instance path equals something, and that's what we have to figure out. So nothing is there now because it found nothing to instantiate to it. So instead of nothing, let's put something. In fact, I'm going to get rid of this for now. We'll rebuild those later if we need them. So I'll say, sprintf really is a cool way of modifying strings. So what we basically want to do is recreate. The moment I deleted those windows, I wanted it back, of course. What we want to do is recreate the path to these things. So I'm just going to copy this wholesale, come back over here, put it here. Now, so job will be the same. The only thing we need to vary is this f here. So if I just put like 1, it's like that, that should work. So we got the same piece copied to every point. Different sizes, different orientations, but it's all the same piece. So we need to vary this number. And I also want to store it as a separate attribute in case I want to look at it later. So I'm going to say, hey, get me a random number as usual. Base it off of the ID. Add, some random number to it. And then that will give us a number from 0 to 1. Now let's multiply it times the number of pieces that we actually have. So I'll say like number of pieces. And let's just see what that gets us. Oh, well, it'll have to be an integer, so we have to at least do this. Okay, so let's see what that gets us. This is 0 right now. Let's go back over here again to the debris area. Let's grab this value, because that's how many pieces there are. And let's just put it there, paste absolute references. So 10 pieces. So we have that number, and if we look at it, let's look at the choice. Looks like we got numbers going from 0 to 9. So we need to add essentially 1 to this. Oops. So there. 1 to 10. Great. Because again, coming back to the debris area, that's how we wrote them out. We wrote them out from 1 to 10. Cool. So we got that number. Let's just use that number. Let's just put it here. We'll put a %d, d for decimal, and we say comma, and we just say the thing that we want it to be, which is this attribute that we just made. So now if I go here, we can say, sure enough, they are different. Now these two pieces happen to be the same, but we can definitely see that this piece is not this piece, is not that piece. Now we truly have a bunch of randomized pieces. If we wanted to kind of prove that to ourselves, looking at it really should be enough proof, but we can always go to instant path, make sure that these paths make sense. We can see we've got, it's pointing to a whole bunch of different places. So that's what we want. And it is doing up to 10 here, as you can see. Awesome.